Okay, so starting array is part of a line, has a beginning point, and it goes on forever in one direction. It begins but never ends, and you can't measure it because it goes on for infinity. To name array, so you may have seen this on Alex already this week. If you have array and you have an endpoint, point M, and then there's often points on the array like point N and point P. When you name array, you use this little symbol like this, and you have to put the first letter as the endpoint, M, and then you name another point on that ray. So this would be ray MN, or you could say this is ray MP. You name it by using 2 points, but the first letter has to be the endpoint. So if you're having trouble with that on Alex, that's why the first point has to be the endpoint. Okay, and then here, if you choose a point in a line, and that determines exactly 2 rays called what? Okay, so what it's showing here is you have a ray that goes this way, and then another ray that goes in the exact opposite direction, and this is called opposite rays. So opposite rays form a straight line. They're a straight angle. Since both rays share a common endpoint, opposite rays are collinear. Okay, and then down here we're talking about angles. The formal definition of an angle is it's 2 non-collinear rays with a common endpoint. So you know an angle to look like this. How does this definition make sense? Well, you have a ray that goes this way, and then a ray that goes this way. 2 non-collinear, so they don't form a straight line like this, with a common endpoint makes an angle. And I'm going to draw a second angle over here that we can mark on. Okay, so this angle over here, there is some definition or some vocabulary we need to know associated with an angle. This is a side of the angle, and this is a side. So the 2 rays are sides of the angle. And then this like elbow joint, the corner, is called the vertex of the angle. And then this box as how to name an angle. So for this angle, we're going to mark it with some points and letters, and then look at how to name an angle. So on this ray, I'm going to have point Y. The vertex is point X. And then on this ray, I'll have point Z. And then there'll be this little number right here, a 3. Okay, so when you name an angle, there's different ways to do it, but it has to be a certain way. So one way to name an angle is by the 3 points. When you name the 3 points, the vertex has to be the middle letter. So we can say that this is angle YXZ, or we can say it's ZXY, but the vertex has to be the middle. So we can say this is YXZ or ZXY. The vertex has to be the middle. So when you're identifying an angle, so often like in a problem, it'll say, okay, angle YXZ, you just like connect the dots YXZ, and that's how you identify what angle it's talking about. And same here. And then even if the angle wasn't drawn and you were just given this, you could say that the vertex is X. Like you wouldn't even need to look at the picture because the vertex has to be the middle letter. The other way to name an angle is by the number placed inside the angle. So sometimes there's a little number. So this would be angle 3. And then the third way to name an angle is by the vertex. So this one has vertex X. If there's only one angle with that vertex, we can name it angle X. And we'll see what that means in a second. Okay, then here is just reviewing some of the vocabulary we just did. An angle is a figure formed by 2 blank that have the same endpoint. 2 rays that have the same endpoint. The rays of the angle, so the 2 rays are called sides, and the endpoint is called the vertex. Okay, and then we'll move to the other side. So now we're going to apply it to practice problem. So over here, it says use the figure to name the angles and their parts. So we have this figure over here. There's a lot going on. It says name all the angles that have B as a vertex. So I'm going to look for point B. It's right here. And so all the angles that have B as a vertex would be this angle, like all the ones all the way around. So first I'll name this angle, angle GBA. And then this angle, I could name it by the points. I could say angle ABD, or I could just name it by this number here. So it seems a little bit easier to just name it by the number. So I'll say angle 7, angle 6, and angle 5. All have a vertex B. B says name the sides of angle 5. So I'm going to find angle 5. So 5 is right here. The sides of an angle are rays. So I'd say ray BG and ray BE. Ray BG and ray BE. You could also say ray BF. That would refer to the same thing. And then write another name for angle 6. Let's see. Angle 6 is, I'm going to use a different color. I don't know. I'm running out of colors though. Okay, angle 6 is right here. Write another name for angle 6. Okay, I can name it by the letters. So I could say angle EBD. I could also say angle DBE. Angle DBE, as long as the vertex is the middle letter. Okay, and this part here, it wants us to answer this in terms of this diagram over here. So we have an angle here. This part is the interior of the angle, and this is the exterior part. Okay, so it says an angle divides a plane into 3 distinct parts. Point Q, M, N lie blank the angle. So Q, M, N are on the angle. S and R, point S and R are on the interior of the angle. And P and O out here are exterior. So far, pretty straightforward, pretty simple. Then the next part is reviewing right obtuse and acute angles. Right obtuse and acute angles. I know you've been working on this since like elementary school, so it should be pretty simple at this point. Yep. And for obtuse. Okay, so a right angle measures exactly 90 degrees. And you can recognize it. It has this little square right here, and that signifies that it's a 90-degree angle. That means that these two lines are perpendicular to each other too, which is a word that comes up as well. So measure of angle A right here is equal to 90 degrees. It's a right angle. Then we have obtuse and acute angles. So an obtuse angle is greater, it's open greater than 90 degrees. So it shows this dotted line right here at the 90-degree point, and it's open greater than that. So obtuse angles measure between 90 and 180 degrees. And so measure angle B is less than 180, but greater than 90. And then acute is less than 90 degrees, so it shows a dotted line at 90, and then this is open less than that. So it measures between 0 and 90 degrees. Measure of angle C is less than 90 degrees. How can you remember this? Actually, I remember my high school geometry teacher saying acute, like a cute little baby is how you can remember acute. Is smaller than 90 degrees. And then obtuse, it has the same root as obese. And so that's how I remember obtuse. Obese, obtuse. Obtuse is the bigger one. It's bigger than 90 degrees. And yeah, I won't write that down because I don't know if that's offensive, but it works. Okay, then down here it says use your protractor to measure each angle. Obviously, you probably don't have a protractor on hand. I'm not going to pass out protractors. Protractors are the tool that looks like this with little like angle measures, and then you line up your angle in here, and then you like measure it the degrees like that. I actually assigned an assignment like this on Alex, so you can practice doing it digitally. For right now, we're just going to name these as obtuse or acute just by looking at it. So this one right here, if I was to like sketch out a 90-degree angle, it would be like right here. This is big, open wider than that, so this is an obtuse angle. This one, if I was to sketch out a 90-degree angle, this is smaller than that, so this is an acute angle. This one definitely smaller than 90 degrees, acute angle. This one is open greater than 90, so if I was to draw a perpendicular line here, this is open bigger than that, so this is obtuse. Acute. This one, it's acute as well. That might be kind of hard, but yeah, if you were to sketch out 90, it would be right here, and this is smaller. Okay, when you're done with that, flip to the back. Okay, so a little key concepts vocabulary right here. You've already seen this word before, so it's not completely new. Congruent. So we're going to be talking about congruent angles. Angles are angles that have the same measure. So remember that word, congruent, same shape, same size. And it has this symbol. We use that symbol there, like equal in every way. So when we're talking about congruent angles, they have the same angle measure. So these two angles have a 42-degree angle measure, so they are congruent. So we can say that angle G is congruent to angle S. Or another way to write it is measure of angle G is congruent to measure of angle S. Okay. Then the second word that's being introduced, a ray that divides an angle in half is called an angle bisector. Bisect means that it's breaking it exactly into two equal parts. So an angle bisector would be this ray or segment right here that breaks up this angle into two equal parts on both sides. So this part over here, same measure as this over here. So if we're told that this whole thing is like 98 degrees, we could divide that by 2 and get 49 degrees here and 49 degrees here. Or like this plus this equals 98. It's actually called angle addition, which is something that comes up later too, but just so you're tying all the concepts together. Okay, and then we're going to use this concept to do the math problems here. Okay, so in this figure, it says that BD bisects CBA. So we find ray BD right here, and that bisects CBA, this whole thing. So it says find the measure of CBD right here and CBA, which is the whole thing. So CBD is right here, and since it bisects, this is the same measure as this. It shows 65 degrees right here. It's like very tiny. So this is 65 degrees as well. So CBD is 65 degrees. And then it asks for the measure of the whole thing. So CBA, did you put, say 130? Yeah. That's right. CBA, some people have trouble like identifying what angle it's talking about. Just connect the dots. So CBA, like that. You connect the dots, so it's talking about this whole thing. And then to find the measure of that whole thing, just 65 plus 65 equals 130 degrees. Okay, then the next one, building on that concept, it says BT now bisects ABC. So BT is the angle bisector. So that means that this side of the angle is the same measure as this. Find the value of x, then find the measure of the angle. So since these two angles are the same on both sides, we can set these equal to solve for x. So we do 3x plus 13 equals 5x minus 17. Okay, and then from here, we're going to solve the equation. So subtract 3x from both sides. 13 equals 2x minus 17. Add 17. I get 30 equals 2x. I ran out of room here, so I'm just putting it over here. Divide by 2, and x equals 15. So it did say find the value of x, so this is part of the solution. It also says find the measure of the angles. So once I have x equals 15, I need to plug that in. 3 times 15 plus 13. 45 plus 13 is 58 degrees. So this here, 58 degrees. Since this is an angle bisector, both of these are the same. This is 58 as well. You could solve it out if you wanted to or just wanted to check yourself, but that's the answer. So this is also a solution as well. Okay, the next one, try it on your own. Try it. So it's going to solve the exact same way as we just did it. So see how far you can get without me. BD bisects. So this is the same as this. I'll unfreeze this so you can see where I'm at. If you got x equals 6, you're a genius. So I set them equal, solved, and got x equals 6. So that's the correct answer to A. Then it says to find the measure of ABC. So you need to identify what angle it's looking for. So ABC is this whole thing. And then what we can do is plug in x equals 6. So 4 times 6 equals 24. So this is 24 degrees. And then here, 3 times 6 plus 6, 18 plus 6 is 24 degrees. And then the last ones, same idea, just give slightly different scenarios so you're prepared for everything. It says BD right here bisects ABC. So this is the same measure as this over here. Find x given the following information. So it says that measure of angle ABC is 98. So to identify that angle, just connect the dots ABC. Cool. So it's saying this whole thing is 98 degrees. Since these are the same measure, if this is 5x minus 11, so is this. And then you could say this plus this equals 98. So 5x minus 11 plus 5x minus 11 equals 98. We can solve for x. So you combine like terms, I get 10x, this and this, minus 22, plus 22, 10x equals 120, x equals 12. And for the sake of being thorough, we'll just finish it out, the last one. It says measure of ABC is 9x plus 87. So ABC, this whole thing, is 9x plus 87. They also told us that BD is the angle bisector. So that means that this side of the angle is the same as this. So this over here must be 8x minus 16 as well. Different ways to set this up. You could do this plus this equals 9x plus 87. Or you could just say 2 8x minus 16 equals 9x plus 87. Kind of whatever works for your brain. And 16x minus 2 times, so when you distribute, you have to multiply by both of these numbers. 2 times negative 16 is negative 32. And I'm just solving at this point. '87 plus 32 is 119. X equals 17. That's all. Okay. Once you get that down, you're going to do your homework on Schoology. It's pretty quick. If you have questions, let me know. So you're just going to do homework 1-5. You can grab a laptop. Homework 1-5 on Schoology. And then if you finish it, log on to Alex and start your Alex as well. To do and work weekly Alex.